Hello everyone. So in this lecture video I will be talking about geothermal heating and cooling, which is actually another form of renewable energy as well as other types of renewable energy sources. So in this first slide, what is being shown is the three main modes of harnessing geothermal energy directly from the Earth's crust into the electrical grid. Okay, so this is not for home use, this is for grid electrical generation. Okay, so there are three types shown here, and you probably will read this in the more more expanded version in the PowerPoint slides. But you actually have direct steam, so this is actually steam generation. You actually have, in this case, flash steam generation, and then you have binary system generation. Okay, so they basically function the same. In the first instance, which is the steam, geothermal production, what actually happens is you're actually getting, in this case, steam directly from the ground. It gets pumped up, and that actually then turns a turbine, which obviously transforms the thermal energy from the actual steam into mechanical energy. That turning of the turbine then creates electricity, and obviously that electricity then gets transferred into an electrical grid. Okay, so that's actually how that works. And what happens is obviously steam is just gaseous water or water in the gas phase. All right, so what happens is that steam that gets cooled down in a condenser, and obviously if it gets cooled down, what happens? It becomes liquid water, and then it gets pumped back into the actual geothermal zone. All right, so that's actually how steam, direct steam generation is. In the second instance, which is called flash steam, this is actually the most common way of generating electricity via geothermal sources. What happens is you actually take, in this case, hot water, pressurized hot water, okay, from the ground. And what happens is, I don't know if you know this, but if you pressurize hot water, if it gets from a very, very small diameter pipe into an area in which there's a big diameter, what happens is that hot water then expands and it actually creates steam. All right. I don't know if you've ever done this. If you ever boiled water and you actually put like a cover on top of the pot that has boiling water, when you take out the top, you'll actually see this steam that comes out, right? So that's actually the same mechanism for generating power this way. So this is the most common. And again, the difference in pressure between the pipe and obviously in this case this container creates that steam, and obviously that steam again turns the turbine, generates electricity, and that, in this case, the steam is then again transformed back into water by cooling. So that's the second form. In the last form, which is called the binary system, the reason why it's called binary is because you actually have two compounds. It's not just liquid from the geothermal zone. You actually have liquid from the geothermal zone, and you actually have a different substance. In this case, it's actually shown as isobutane. Okay, so what that is the heat coming from the geothermal zone is not hot enough. So what you're doing is you're actually using, okay, again, the heat is not hot enough to actually generate either steam through the direct method or the flash steam method. So what you do is you use that heat, all right, to actually, in this case, make a different substance become a gas, in this case isobutane. Right? So let's just assume that the temperature here is like 110 degrees Fahrenheit, and what happens is that temperature might be enough to actually make the isobutane from a liquid into a gas. And obviously when isobutane becomes a gas, when any liquid becomes a gas, it expands, and that expansion then creates a force that then can turn a turbine, similar to what all these other processes have actually done. And again, similarly in the previous instances, the isobutane gas is cooled down and then turns again back into liquid. It makes contact with a hot liquid. In this case, it's not making direct contact. Okay, so there's actually an interface between these two pipes, and again, it turns into gas, and this whole cycle continues. FYI, the biggest generators of by per capita of, like in this case, of electrical demand from geothermal heating is actually Iceland. Obviously, and the reason why Iceland is obviously very big is because in geothermal power is Iceland is actually in a highly volcanic area, so therefore there's a lot of heat coming from the ground directly or very, very close to the surface. Okay. So now I'm going to switch into like home heating using geothermal. And home heating, ladies and gentlemen, is actually similar to this process. So it's actually a binary heating system. All right. So this is a very, very, very vague and very, very ambiguous schematic. But the whole purpose of geothermal heating and cooling for the home, okay, which is around $30,000, that's an average per household if you want to go to geothermal heating, is in cold days, okay, cold days, so it's cold like right now in Wisconsin, what actually happens is heat is given to the actual home from heat below the ground. Okay, so when it's cold outside, heat comes from the ground. Okay, when it's hot outside, heat goes into the ground. So all you're doing is you're basically either taking heat from the ground or putting heat into the ground, depending on the weather conditions. Okay, and the way that you do this is, I'm not an expert in geothermal power, by the way, but but I know of a couple people who have actually done this. Is what you do is you actually pump a antifreeze water mixture into the ground. Some people do that, some people just do plain water. But obviously if you put antifreeze and water solution to the ground, it becomes more efficient, right? So what happens is, in terms of, let's say if it's cold outside, obviously the heat, like the ground is always going to be a little bit warmer. FYI, if you are below 8 feet from the, if you dig below 8 feet from the ground, this is an average, okay, in the United States, the temperature below 8 feet, from the ground level never ever reaches freezing. It never reaches 0 degrees Celsius. Okay, so and that's the reason why a lot of people dig. Okay, and that's sometimes called, and if you are in construction, you should know this, that is sometimes called the frost line. And this is why people dig foundations below the frost line. Okay, so again, water does not freeze below 8 feet, and to be safe, you actually dig around 10 feet. But if you want to be more efficient, the deeper you dig, the better, if you want to do home health heating and cooling from geothermal. But obviously the problem if you dig deeper is you're probably going to hit some water tables, okay, some water lines, some aquifers, so that's going to be a problem. But anyway, I digress. So what happens is, let's say it's cold, so let's say it's winter in Wisconsin. So what happens is heat then, okay, because obviously it's colder out here, it's warmer underneath the ground, heat basically comes from the ground, and heat gets transferred from the ground into the antifreeze water solution, right? So now that solution is now hotter, not that hot. So what happens then is you actually bring it into a circulating pump, which actually compresses the heat that comes out. And what you do with a compressor is when you compress a warm solution, you actually make the solution hotter, right? So compressing makes it more hotter. So what happens is when you compress that, it becomes hotter, and that heated liquid then makes contact. What you do is you obviously pump air, right, into this whole contraption of tubes, and the heated, basically liquid in this case actually turns the cold air into warm air. And this is actually the opposite in this case. So that's actually how that works during cold weather. Okay, just FYI, there's actually 3 interfaces normally in a geothermal and heating and cooling. You actually normally have antifreeze water solution. You actually normally have a antifreeze water solution interfaced with a refrigerant like R410A, which is the same refrigerant that you can actually find in your air conditioning unit. And obviously the last interface is between the refrigerant and air inside the house. All right, so again, it's the same cycle. The only difference is either you're pumping heat into the ground or you're taking heat from the ground. That's basically the whole purpose behind geothermal heating and cooling. It's much more complicated than that, but I think that is sufficient for this class. All right, there are other renewable types, and I'm just listing 3 here. I think there's more in your PowerPoint slides: hydroelectric, wave, and tidal. And all of this actually takes advantage of water power. So hydroelectric is basically through dams, and what a dam is you just trap water on one side and you don't have a lot of water on the other side. So obviously water then flows from the area in which there's more water into the area that has less water, and so that creates then the turning of the turbine, similar to the geothermal heating, that creates that transform the mechanical energy into electrical energy, and that's how you get hydroelectric power. Again, the problem with damming, obviously, as you know, is you have flooding upstream, then you actually have, in this case, drying downstream from a dam, right? So you, like normally bodies of water that was high before will now be lower in like downstream from a dam. Then you actually have wave power, and wave power basically is self-explanatory. Wave just gets power from the power of waves, right? And tidal, by the way, is actually tidal waves, but the only difference between wave and tidal waves is tidal waves happen because of the pulling and pushing of the moon, and this actually, you normally get 2 tides every 24 hours. You actually get 4 tides every 24 and some few minutes. So I think 25 hours you actually get 4 tides, okay? 2 low tides and 2 high tides. All right, but that normally is felt more, in fact it is felt generally more in oceanic, right, environment. So Lake Michigan will not get any tidal power. All right, so that's obviously a disadvantage for tidal power, and it only happens again 4 times every 25 hours, so you can annually generate power during those times. In wave power, obviously, like regular waves is generated by the wind, right? So this is similar to wind power. So wave power can only be generated during, in this case, during areas or times in which there's actually high winds, right? The interesting thing about wave power, if you think about it, is wave power is generated by wind, and wind power is actually generated by the sun. So indirectly speaking, wave power is still a manifestation of solar power. All right, there are other renewable types out there. I'm actually going to show you in this case, probably a 10-minute video on like other renewable types. It's a little bit outdated, but just to give you a hint of what the future looks like in renewable energy sources, and that will probably be the basis of our discussion for this week. All right, so on that note, have a good day, and I hope you stay warm.